Welcome to the Crazy Hat Chemist. So today we're doing another video on thermochemistry. So let's get moving. Bam! So today we're going to be talking about enthalpy, which is H, but specifically change in enthalpy because you cannot measure enthalpy directly. Okay, so I'm going to give you a definition here to start off with, and it's a very complicated, detailed definition, so follow along. Energy changes in a reaction are due to making and breaking chemical bonds. In addition, molecules have rotational, vibrational, and translational energy, as well as nuclear energy. So, rotational energy is moving in a circle, so spinning of a molecule around a bond, for example. Vibrational is vibrating, and translational energy is movement from one location to another location. So hopefully that makes sense. Ooh, that which just had translational energy. Okay, and nuclear energy, that's in the nucleus itself. These combine to make up the total energy of the system. Enthalpy, or delta H, is the internal energy of the system plus the product of the pressure and the volume, which is equivalent to the total heat content of the system. And we actually have already discussed this, and that's why we have the Q. The Q is equal to the mass, specific heat, final temperature, and initial temperature difference there. Okay? Enthalpy is independent of the path, therefore it is called a state function. An example of a state function is your bank account. So it doesn't matter if you have $100 in your bank account, you could have arrived there by putting 1 penny in there every day for 100 days, or you could have gotten a $100 bill and put that in there in 1 day. So it is path independent. Okay? If the system liberates heat, if it gives off heat to its surroundings or the temperature increases, i.e. it warms, then the enthalpy change, the delta H that is going to be negative, and it is exothermic. Okay? If the system requires heat, absorbs heat from its surroundings, and the temperature decreases or cools, then the enthalpy change, or delta H, is positive and endothermic. Okay, that's why the exothermic one is in red, the endothermic one is in blue. Exothermic, liberating heat, getting warmer. Endothermic, taking in heat and getting cooler. Okay? And then heat always flows from the hot object to the cold object spontaneously. Okay, so hopefully you have experienced this at some point in your life, and that is maybe you have taken your hand and held somebody else's hand. Whoever has the warmer hand, you are transferring heat to the cooler hand person. Or, if you will, in the wintertime, if you were to go hug a tree, there's not a whole lot of difference between you and the tree as far as the temperature that you can notice. But if you take a metal pole or the hood of a car, you are going to be warmer, and you touch the hood of that car, you are the warm, hot object, and you are transferring heat or energy to that cold metal object in the wintertime. Okay? I'm going to show you a couple of graphs and then also a diagram of what this is as well. So enthalpy change, we're still on that. I want you to look at this. This is an energy on the y-axis and reaction progress on the x-axis. A and B are reactants. C is a product. This is an exothermic reaction. It is an exothermic reaction because the product is lower in energy, the C, the product is lower in energy than the reactants are. Okay? And the reverse is true here. This is an endothermic reaction because the product, that is C, is higher in energy than the reactants of A and B. Same type of graph. Okay? Here is the system. Here is the surroundings. This is dealing with the physics thing. If you've already taken physics, you're probably in good shape with the system and the surroundings. If heat is released by the system, that means that Q is less than 0. Therefore, Q is negative. And then work is done by the system. Okay? If heat is absorbed by the system, that means that Q is greater than 0. And that means that work is done on the system. Okay? All right. That was another video here. And so outside, it's really cold. That's why I'm wearing this long sleeve shirt. And I need to put on another hat. And this hat is going to keep my ears warm. Okay? I think this was made with llama wool. If you like that video, give me a thumbs up. Please subscribe to my YouTube channel. I greatly appreciate that. And have a great day. See you next time. Bye now.